In physics, energy is defined as the capacity to do work. Work is done when a force causes an object to move over a distance. A fundamental principle is the conservation of energy, which states that energy cannot be created or destroyed, only transformed from one form to another or transferred from one system to another. The standard SI unit for energy, and also for work, is the joule, symbolized by a capital J. 1 joule is defined as the amount of energy transferred, or work done, when a force of 1 Newton moves an object 1 meter in the direction of the force. This can also be expressed in base units as kilogram meters squared per second squared. Kinetic energy, or KE, is the energy an object possesses due to its motion. The formula for kinetic energy is 1/2 times the mass of the object times the velocity of the object squared. Here, m represents mass in kilograms, and v represents velocity in meters per second. Gravitational potential energy, or PE sub g, is the energy an object possesses due to its position in a gravitational field. It's commonly calculated near the Earth's surface. The formula for gravitational potential energy is mass times little g, the acceleration due to gravity, times height. M is mass in kilograms. G is the acceleration due to gravity, approximately 9.8 meters per second squared near Earth's surface, and h is the height in meters above a reference point. Let's work through an example. A bowling ball with a mass of 6 kilograms is rolling down the lane at a speed of 5 meters per second. What is the kinetic energy of the bowling ball? First, identify what we know. Mass, m, is 6 kilograms, and speed, v, is 5 meters per second. The formula for kinetic energy is Ke equals 1/2 mv squared. Substituting our values, Ke equals 1/2 times 6 kilograms times 5 meters per second, quantity squared. Squaring the speed gives us 25 meters squared per second squared. Multiplying, we find Ke is 75 joules. So the kinetic energy of the bowling ball is 75 joules.